Hello students, welcome to In 5 Minutes. Now we'll be solving May 15 paper for complex Fourier series. So question number 4a. If f of x is equal to c1 into q1 of x plus c2 into q2 of x plus c3 into q3 of x, where c1, c2, c3 are constants and q1, q2, q3 are orthonormal sets on a comma b, show that integration a to b f of x the whole square dx, that is c1 square, c2 square, c3 square. So let's solve this solution. I just define since q1, q2, q3 are orthonormal, therefore a to b q1 of x the whole square dx, that's equal to a to b q2 of x the whole square dx plus a to b q3 of x the whole square dx, that is equal to 1, and a to b I can say qm of x into qn of x dx, that is equal to 0 when m is not equal to n. That means you have shown here clearly that m and n, that means q1 q2 combination will be 0, q2 q3 combination will be 0, or q1 q3 combination will 0. So that's my basic condition whenever q1 q2 q3 are orthonormal. So integration a to b f of x the whole square dx, that is equal to a to b c1 q1 of x, c2 q2 of x, c3 q3 of x dx, the square of that. So we can write as integration a to b c1 square q1 square of x plus c2 square q2 square of x plus c3 square q3 square of x plus 2 c1 c2 q1 of x q2 of x plus 2 c2 c3 q2 of x q3 of x plus 2 c1 c3 q1 of x q3 of x, and that is dx. So when we separate integration, what we can say, c1 square a to b q1 square of x dx plus c2 square a to b q2 square of x dx plus c3 square a to b q3 square of x dx plus the rest term is 2 c1 c2 integration a to b q1 of x q2 of x dx plus 2 c2 c3 a to b q2 of x q3 of x dx plus 2 c1 c3 a to b q1 of x q3 of x dx. So now this can be written as c1 square plus c2 square plus c3 square, because as you know students, integration a to b q1 square the same as q2 square and q3 square, this are having values of 1. So I can say this is 1, this is 1, this is 1, and this comes to be 0, 0 and 0. So hence we can say that a to b function square dx is c1 square plus c2 square plus c3 square, and that completes my sum. Thank you for watching video on In 5 Minutes.